Hello, good evening, everyone. So this is the first revision session for NTERM. So we start off with week one, and then week two, three, and so on. So in case you have any questions, please feel free to interrupt and ask. Okay. Okay. So week one kind of starts off with a lot of introduction, and there is basically very little Java. Most of the things are theoretical, and these are required to understand whatever are being taught in the later weeks. So, for instance, is variables and there's memory management and what inheritance means and all these things, right? So, we'll do a quick recap of um, these ideas and then we'll go ahead with the actual Java classes and objects. Okay. Okay. So, first, again, I'll just write the main keywords here and then just briefly explain whatever I'm writing. Okay. So, yeah, we looked at what programming languages are, right? Programming languages actually help you to communicate between humans and machines. Like it enables you to write programs in a certain language which is uh, translated by what are known as translators, right? So the computers can only understand machine language, right, which is kind of the zeros and ones, a sequence of zeros and ones. So you write a program in a high level language and these translators will convert high level language into machine language. Translators generally are of two types. One is compilers and the other is interpreters. So compilers are which will convert the full program into machine code and then start executing. In the case of interpreters, it will take one line at a time, execute that line, and then go to the next line. Rather, take one line, convert it to a machine code, execute it, and then go to the next line, right? So for there are different programming languages use either by compilers or interpreters, and that's pretty much uh, you know. we don't have to be aware of unless we are worried about the speed or accessibility or the I would say the performance related, right? How fast your program has to respond and all that. Until that does not matter, you don't even have to know whether it is a compiler or an interpreter, right? Just give me a second. Yeah. So we also looked at what is known as like two kinds of programming. One is imperative programming and the other is declarative. So in the sorry. So in the imperative programming, say for instance you write a for loop, right? And you say if something is there, you do something, etc. etc. Right? So this you're actually telling step by step as to what you want to do. Whereas in the case of declarative, you would merely say this is what I need. Say say for instance, yeah, SQL is a very good example of declarative programming, where you tell that okay, these are the records which I need which satisfy this condition. How it is handled by the database management system, right? The DBMS actually converts whatever query you have into how it has to be done. Say for instance, you go to this table, you index it by this, you take the first one, you take this one, sort it inside this, and those are actually taken care of by the DBMS. So declarative style of programming is where you simply say what you want. So in our case also, like in week, I think week 9, we have the lambda expressions, right, where we simply say. So yeah, so you I don't know if you recall this, but you had these lambda expressions where you simply say you want to filter, say certain things which satisfy this condition, right? Say by ns rather than whatever you want, you filter kind of say, and that you say that this is what you, and you are not specifically telling like what how exactly to go about it. So these are examples of declarative programming. Now in programming languages, an important thing that you should know is variables. What are variables? So you have memory locations in the main memory, right? So there are many memory locations where you store these variables. So each of these memory locations are actually identified by some names which you can assign basically. You can have variable names which are as big as permitted by the programming language. The maximum cap on the number of characters that each variable can have is defined by the programming language. So the variables can have. So it's more like a name for a memory location. While the program is being executed, there is a memory location being allocated, and everything that you want to do that location, you will identify it using this variable. Like for instance, if you want to increment the value of this, you will say that whatever is here, right? So a is a plus b. So this is what you would do, right? So this is the variables are nothing but some kind of an identifier or a name for a memory location. So okay. The other important thing is how function calls are made in programs, right? So you have a main method, right? And then you have another function which is being called from here. You have a set of statements here, you have a set of statements here, right? Now, function is defined here like this. And from here, you're calling say f1, right? So your f1 is defined like this. Now, internally, what happens, right? So in Java specifically, you know that the program execution starts from main. And whenever there is a method being invoked, what happens is there is something known as a stack of activation records. So each activation record corresponds to one method, or rather all the details pertaining to a method. Say, for instance, the local variables, the object references to the dynamic variable. Say, for instance, if you have a student object, you have the name of the student object or the variable which is referring to the student object, right? So those things are there, and then you have a few other things which I'll actually come to. So there is something called a stack of activation records. So what does the activation record contain? Activation record contains local variables, and you have the return link. So return link is the location where you store the, or rather return link is the address of the location where you have to store the value of the returning method. When we see this example, we'll just see what it is. Then you have control link. Control link will actually take you back to the previous activation record that again I'll show you with this example. Okay. So there is this what is known as a stack of activation records. So for each activation record, it actually corresponds to the information pertaining to one method. So for main, you have one activation record. For function, you have one activation record. For F1, you have one activation record. Suppose this F1 is a recursive function, right? For each function call, there is an activation record created. Okay. So it is not like for a particular name or named method there is an activation. It is like for every function call there is an activation record. So let us see how the just one second. Let us see how the stack looks. Okay. So for now, please assume that this is the stack. Okay. Generally, stack can be from top to bottom or bottom to top, whatever. The top of stack is the latest entry into the stack. Okay. So that is something. So you can look at the stack like this or like this. You can say that this is the top, and when you keep adding records, this will top will point here. You keep adding records, it will point here, or it could be like building from bottom to top. So you keep adding something, top gets moved up. Okay, so you can visualize it either way you want. All that you have to understand is the top of stack, top of a stack is the latest element in that stack. Okay, so for now, let us just assume like this. Okay, so first, what is a function being called here? First function being called here is the main, which is where the execution starts from. So you have main here, right? So from inside main, there are so many steps which are being executed. Right? So these things keep happening. And when there is a function call which is happening to another method, okay, go check here, and there is an activation record for a function fun created, and that is actually pushed inside this stack. And then while this is being executed, you have things are these lines are getting executed, and when it reaches this line, an activation record for this gets added here, right? So that function control goes to this code, and then you have another function call happening here. So until that base condition is satisfied, just give me a second. Until the base condition is satisfied, right, you will keep on calling the f1, f1, etc. So let us assume that this is not a recursive call, just for the sake of easier understanding. Okay, so now this is the top of the stack, right? So these lines are getting executed here. Now this is returning, say, return some value, say x. Okay. So what happens here is this, whatever return value is here, it will actually be taken into one variable, say x1. So then once this return is executed and the control is transferred back to the calling function, this activation record is popped out. So the role of this function is over. So this activation record is popped out. And now you have the function, I mean, the rest of the steps inside this function to be executed. So you can see these steps are getting executed, and you can see the function is here. And then after, again, you have a return statement here. And once it finishes, the control is again transferred back here, and you have so many instances. So when the control is being transferred here, this is also popped outside, and then the main method will continue with the execution of the code, right? And once the main is also over, the stack becomes empty. Now, few things that you have to understand is, as I said, the structure of the activation. So the local variables, right? Say for instance, you have, say, int a comma b. So this values, right, they'll be available inside this method. So there is an int a comma b function, which are like appearing as variables a and b here. So let us assume that okay, f1 is executing now, right? Now it is returning a value x. Now this will have a return link. Okay, this is nothing but a memory location address. So it will be something like a hexadecimal, say A0032 or something like that. This will be some memory location here, right, where it has to store this value x. Now, when this function is exiting, we are going to remove the pop this full activation record. Popping means now this activation record is no more accessible, right? But whatever it has computed, this x value has to be accessible from function. So it will return. There will be a return link. If there is an address here, so here the value of the x will get stored. Okay. Now the value of whatever are the values which are required for A and B and everything, that will get executed, and then it will go to me. Now what happens if this, instead of int, this is something like a, say, student is. Okay. Now this is s here, right? Sorry. So here you have s, right? Now s is an object, or rather it is a variable of type student. The actual memory location for the student is allocated not inside the activation record, but in, or rather the stack, but it is allocated at some place which is known as the heap. Okay, so in heap, you have this S. So the student may have a name, the student may have a roll number, the student may have so many things. So this is actually pointing, this is a variable of type student, but the actual memory location or the memory allocation for the student is done in the heap. So internally, you have to look at something like this. Okay. So this is the stack. As I was showing the stack here, I've shown it as growing above, but here you can see it as a stack coming down. So like for instance, main is here, function is here, f1 is here, etc. So stack keeps growing here, and there is this heap which is here. So this grows above and this grows below. And when at some point there is this recursive calls and all that which will not have base, then what happens is it will just keep populating, and it will keep overwriting the heap. That's when you get the stack overflow error. Okay, so for that you can ignore for now. It starts to come into occupying the heap space. That's when you get this overflow error and all that. For now, you can just understand the stack grows in this direction and the heap location grows in this direction. So if there is an S variable which is of student, right? For that, the memory location is being allocated inside the heap. Okay. So this is the This is something that is very important for you to remember, because this is important with respect to the call by value, call by reference, and all that, right? So when it is a call by value, it's actually the value gets saved here. Say for instance, or that I'll come to that, but it's important to remember this. If it is a local variable, it gets value is actually getting stored here, whereas if it is an object, there is only a variable which is here, but the actual memory allocation is happening in what is known as the heap. This heap is different from the data structure heap that you have learned. This heap is just another name for a dynamic, the dynamic memory allocation area inside the main memory. Okay. Now, yeah, the return link I have already mentioned, like whatever you want to store this value, you want to put it here. Control link is once you see, depending on the method and how much of data that method needs, the size of the activation record will vary from one method to other. So once one method finishes execution, it should know where to go back, right? Where is the starting of the next activation record? So the control link will actually point to the starting address of the previous activation record. So these are the main things. This might differ based on implementation and architecture and lots of other things. But these are basic things. There are many more things also in this activation record. But for now, you just need to understand these things. Okay. Yeah. Any questions?
No, ma'am.
Okay. Yeah. Now you have what are known as data types. So what is the purpose of data types, right? So you have integer, basic primitive data types, integer, float, double, etc. And then you also have, so these are primitive. Okay? Then you also have user defined data types, like the classes that we have, right? The classes that we define are user defined data types. But before going to that, why do we even need data types, right? So in the memory location, the main memory, these data are all stored as sequence of zeros and ones. So 0 1 1 0 0 0 0, something like this, right? So everywhere you just take a snapshot of the memory, right? It will all be zeros and ones. So if this whatever data is there inside the memory has to make sense, then you have to attach some logical meaning to these um, memory locations. And you say that for every memory location, say for instance, this is, say I am identifying it by the name X. I want to know whether X represents an integer, double, string, or whether it corresponds to a student or whatever. Right? So the data type is important in order to make a logical meaning out of this sequence of zeros and ones which are there in the memory. So these primitive data types, in with respect to most of the programming languages, the primitive data types will have a standard memory size which is allocated. Maybe it depends on the version of the thing that you are using. It depends on the operating system. It depends on multiple other things. But there is a standard number of bits that are allocated. So integer sometimes has this 32 bit, and I think float the 64. I don't remember exactly, or something like this. So what I'm saying is, so if this is 1 byte, say 8 bits, right? So the first four locations together will indicate the variable x, because it is int x. Then 1 byte is 8 bits. So if it's a 32-bit location, right? So in the first four memory locations will actually correspond to the variable x, and those will be accessed together. And because you have identified four of them together as one data type, they'll be accessed together, processed together. Otherwise, it doesn't make sense. No, the first few bits of the number is processed. The last two bits are not. I mean, last few bits are processed differently, right? So that's not possible. So when you say an integer which is of 32-bit size, and you've identified x as an integer, then these 4 bytes are accessed together. So internally, I mean, there is a lot more that happens, but just to give you an idea of what is happening. Okay. Now, so what exactly is a data type, right? So when you say an integer, you know what it is, right? So there is a value, right? This value is something like, it can be a negative value, which is a negative value which does not have a decimal, right? It can be a zero or it can be a positive value. So I'm saying like some negative value x or positive value x or zero without any decimals. This is what an integer is. So the data corresponding to an integer is nothing but this value. Whatever this one value that you're specifying, that is a data. And what are the operations which are permitted on this int? You can have plus, you can have minus, you can have division, you can have multiplication. All these are standard operations which are permitted on a data type. Again, whatever operations are permitted on data type is again specified by the specific programming language on which these are defined. So you have these basic operations which are doable on a given data. When you have a user defined data type also, this is exactly what you're doing. Say for instance, you are defining something of type student, then it has a certain data. Say for instance, int name, sorry, because it's a user defined data type, it has, for each data inside it has a primitive data type, right? And int roll number, etc. And then you have methods here which define the operations which are permissible on this data. So all the operations that we are doing are in a way working on the data for that user defined data type, right? So just like the primitive data type has a certain data and a permissible set of operations, just like that, any user defined data type will also have a set of data and a set of operations which are acceptable. Okay, so these are actually what we refer to user defined data types, and this is what we generally do in Java by declaring classes. Okay, classes are nothing but some user defined data types. Now, yeah. So we just mentioned that every variable that we use, right, it has some data type, right? So every variable that we use, whether it is I mean, primitive data type or user defined data type or whatever variable you are using, it has some data type. But do you need to specify it before you actually start using it, right? That's the question. In the case of dynamic versus static, this is the discussion that happens. In the case of dynamic, you simply say x equal to 10. The language will know that x is an integer. So if you put something like this, it will interpret it as the basic data, which is double possibly. Right? So you declare you don't say ahead as to okay, you have to allocate 32 bits. So I'll just stick to integer so that yeah. So I'm not going to say in advance that x has to occupy 32 bits. I'm just going to say x has value 10. Then the compiler, sorry, the programming language, whatever is the translator, the compiler, right, that will actually interpret this variable to be of type int. This is the dynamic typing. In the case of static typing, you have to explicitly say that this is variable of type x, and when you are allocating memory location, you please allocate 32 bits for this variable. So the difference between dynamic and static must be very clear for you by now, because in Python you always use dynamic typing. You don't specify the data type of the variable, right? Just by say you give something like x equal to this, then you know that there's a list. So you say something like x equal to, yeah, this, then you know that it is a string and all these things. So it's the data type of the variable, right, that is actually something which is decided dynamically during runtime, and that is a dynamic typing. In the case of Java, which is very specific about the types, in general we have to declare this, but there is also other options like type inference. Even then you have to use this variable, you have to use this keyword where to denote that the the compiler has to spend some time thinking about what this variable could be, what type could this variable possibly be, by looking at the value that is coming inside it. So you cannot simply say x equal to 10. You can say var x equal to 10. Even here you are actually warning the compiler, see, this is a variable which for which you have to do some kind of an inquiry about the data type based on the value that is going to come inside the variable. Okay. So Java is strictly static binding, you can say that, whereas Python is all dynamic. And we also know the advantage versus disadvantage of dynamic and static typing. So dynamic typing, the programmer, it's quite easy, but static typing, it's much easier to catch the bugs early on, because if you make a small typo in the variable name, right? I mean, yeah. Somebody wants to ask something.
Ma'am, when we write var x in Java, like
Huh.
so, does Java come to know its type during runtime or compile time?
Sorry, does Java come to know?
Its type during runtime or compile time?
It's during compile time because we will initialize the variable at the time of declaration itself.
We cannot write
No,
while.
no, no. I think Mehak is asking about this, right?
Yes.
Yeah,
Does
yes,
this happen compile time or
Yes.
runtime, right?
yeah, it will happen at compile time only, no, ma'am, because we should initialize at the time of this variable at the time of declaration itself. Like where x equal to 10, we should specify. If
No,
not, the
that is okay. But can it take something like new student or something? I mean, some
yeah,
student is coming inside, right? That is decided during runtime. No? No, I'm not sure. I have to check it, Mehak. I have to check how, where does this. So Nalini, yeah, I mean Nalini says Nalini normally explains the type inference part. So I think she knows better. So do you want to cross check, or are you sure
yeah,
it is
I will,
compiled?
I will cross check and yeah,
Okay,
yeah,
okay. We can just check it.
yeah,
Yeah,
yeah.
then we can confirm it. Yeah,
Mm,
Okay, thank you.
okay, ma'am.
yeah. Okay. Uh, so dynamic versus static. Just give me a second. Yeah. Okay. Now we have what is known as the scope versus lifetime of variables. Right? Okay. So as I was just mentioning, you have a method main, right? Here you have say int x. Okay. Then there are so many things that you're doing, and then you are having this function called. There are so many things you're doing, and inside function, say you have variable y, right? Then you are calling f1. Then you have function f1. Here you have say int z. Okay. Now, as you can, this is main. Okay. And you have this variable x here, and you have function, and you have this variable y here, and you have f1. So you are now currently executing f1, and you have z here, right? Now, throughout this function f1, right, this variable z is, you can access it in the sense that you can check what the value it has. You can you can update the value of that variable. You can modify. I mean, you can use that variable for so many other operations and everything. So basically, this variable z is very much accessible with an f, right? So what happens is, um, yeah. So z, we say that at this point z, the variable z is in scope, is what we say. Okay. Now, once the f exits, right, this variable z is no more in scope. This variable cannot be accessed, and this variable z is no more in scope. And now the function, this function is getting executed, and therefore this variable y is in scope. And this, when the function also exits, the variable y is also destroyed, and the function y is no more in scope. What lifetime means is that even though this when even f1 was getting executed, right, this variable y was still allocated memory inside the stack of activation records. This is still very much allocated a memory location in the stack of activation records, and hence this variable is still alive and is in its lifetime. So even though this variable y, you cannot access y equal to something from here, it doesn't make sense because the y is local to the function one, right? So y is not accessible here. So y is not in scope, but y is still alive and is in its lifetime even while execution of f1 is going on. So that is the difference between scope and lifetime. So as you can see, those variables which are on top of the activation record, right? These are accessible, and hence all the variables inside the activation record which is on top of the stack are accessible and are in scope, whereas all the variables in the stack, they are alive and are in their lifetime. So the moment this pops out, this is no more alive. Z is no more alive, and the lifetime of Z is over. Yeah, somebody wants to ask something. Okay. So Z is not in its lifetime and cannot be accessed anymore. The scope is not there, lifetime is not there. Whereas when the this function with this y is getting, sorry, the function is getting executed, y is in scope and in lifetime, whereas x is not in scope but is in its lifetime and is live. So this is the difference between the scope and the lifetime. Okay. Now there is something called as call by value versus call by reference. Okay. So I have say function in x is doing something, whereas I have function 1 where student s is doing something. Okay. Now I'm going to make a call from here, say function of 10 and function 1 of some student object s1. Okay. Whatever changes I do to x, right, x plus 1, and even this whatever changes I'm going to make to x, it is not going to, okay, so this 10 doesn't make sense here. Let me just put another variable. Okay, so whatever changes I'm making inside the function to the variable x, it is not going to affect the value of y. This is because this is what we known as call, what we refer to as call by value. In this case, a copy of the variable value y is being created in x. So there is a y which gets 10 and there is an x which gets 10. When you say x equal to x plus 1, this gets updated as 11. That's it. The y value does not change. Whereas if you do something to like student objects, right? I mean student object or something like objects which are coming into the um, argument. Say for instance, I'll just put an array that says right, student, okay, A. Now I'm going to put say A1. Okay. What I'm going to do is say A1 of 1 equal to A1 of 1 plus 3. I'm going to update it like this. Then, not A1, so maybe A2. A1 is the other one. It doesn't matter because internally it doesn't matter. So, oops, sorry. A equal to A of 1 equal to A of 1 plus 1. I'm going to update the second element of this array. I'm going to increment that. Then now A and A1, when I'm making this call of an object and not a primitive data type, right, which is an array here, right? What is happening is the heap location is there, right, where I have this variable A1. A1 is the one which is coming first, no? This one. Now when I am passing this one, the A is also going to start pointing to the same memory location as given by the A1. So whatever you update here, right, that will get updated in A1 as well. So I'm just going to update for A. That's what I'm thinking. But eventually A1 also gets updated. This is called by reference. You're actually uh, what do you say? You are not copying the value. Instead, you are actually making the two variables point to the same memory location, because this allocation of A1 and A and everything, no, this is happening in the heap. Whereas in the case of X and Y and everything, because these are local variables, this will be like there as part of the method, sorry, the activation record itself. These objects which are dynamically allocated, which are happening inside the heap, now both will point to the same memory location. So any change you do to the A variable inside this method, that will get reflected in this A1 variable also, because both of them are pointing to the same object. Okay. So this is the call by reference and call by value, the difference between call by reference and call by value. Okay. Yeah, so I've already mentioned about stack versus heap. So in the case of stack versus heap, the one other important thing that you have to remember is that in the case of stacks, like when one function is executing like popped out, right, this memory is cleared. So if you want to add another activation record, it will again get added here. You don't have to free up this memory space, because the return link is now pointing to previous memory link. Right? These memory locations are deemed to be released. In the case of heap, what happens is, suppose this method, sorry, so this function is actually updating some student record, which is okay. this is actually updating some value in the heap, right? Now the calling function should also access this heap, say some linked list or something. I'm calling a delete method of the linked list, delete node, okay, delete some node X or something. I'm calling this, and from the main method I've called delete, say node 1 or something, okay. I've invoked this method. Now, what I want to do is whatever linked list was here, right? This method, whatever linked list was there, I want to have access to the same linked list with just this node 1 removed. So if the activation record, if I remove the full linked list, right, I won't be able to access it. So in the heap, you allocate the memory for the linked list, and inside the method, you have edited such that it has removed a particular node, and then that same linked list, the modified linked list, has to be accessible by the calling function. Yeah, calling function, right? So what happens is, when does this memory get freed up? So when does the system know that okay, this linked list may not be needed at all? It might never know, because it might see if there are 10 function calls, and at some point after the fifth function call it is not required, there is no way to communicate it to the program, right? So what happens in the case of heap is this cleaning up of memory location, freeing up of memory space has to happen. Either the system has to do it, the JVM plus the OS has to do some kind of cleaning up via some method known as garbage collection, or the programmer itself has to write the code to memory. I mean, deallocate the memory. Say, for instance, the fifth call, I know that I'm not going to need this linked list anymore, and I will write some dealloc method, or I'll invoke some dealloc method or something, which is given again by the programming language to mention that okay, I'm not going to need this memory location anymore. Please free up the space. So two ways that in Java, it is a automatic garbage collector which will get invoked, once in, I am not sure the frequency, but it's actually invoked by the JVM and the operating system together. And memory locations which have not been used for a long time, or which do not have any pointers pointing to it, right? So what happens is, if there is a, say, L memory location which is pointing here, then I know that this is required. But if I know that there is this memory location which does not have any variable which is pointing to it, then we know that this memory location is not required. So such memory locations are freed up by the garbage collector. So this is the stack versus heap difference. Stacks, these are automatically cleared once the activation record is popped up, that memory is available for further use. In the case of heap, you have to do it manually. Then, yeah, so then the object oriented programming. Yeah,
Heap is for automatic garbage collector, right?
sorry,
Heap is for automatic garbage collector, right? Heap,
heap is for.
automatic garbage collector.
No, that's what I'm saying. See, memory location inside the heap can be deallocated in two ways. One is the programmer has to write the deallocation code, or the JVM or the operating system will invoke the garbage collector occasionally. There are two ways to do that.
Then not for stack, right? We cannot use automatic garbage collector for stack.
It is not required, is what I'm saying. When the function pops out, then function record is over. That activation record is automatically popped out, and that memory location is free for use. The idea of memory deallocation is that that memory should be available for other variables to be allocated, right? So if you keep on adding without deallocating the memory, at some point the memory is going to become full. So you have to deallocate the memory which you don't need anymore. In stack, it happens automatically because the activation record gets popped out. Whereas the case of heap, it has to be done explicitly either via an automatic garbage collector, or via method deallocation invoked by the programmer.
Okay, ma'am. Yes, ma'am.
Is it clear? Okay. So in the case of object-oriented programming, Sir is talking about four concepts. One is the abstraction, the other is subtyping, then you have dynamic lookup, and then you have inheritance, right? So abstraction, as I told you, the abstraction is, you have the public interface and private implementation. So this is something that we have already seen earlier. So public interface is, so interface, you can, when you have a behavior of a program, right? Say, for instance, as I told you, sir, if it is a integer, you can do the addition, subtraction, that thing. So in the case of, say, you have a The collections, I used to tell the same example, right? The collections dot sort. You are using this method without actually knowing what the sort method does, how the sorting algorithm is implemented, right? It could be any sorting algorithm that we have learned. I mean, or possibly you have not learned or you're yet to learn or whatever. What sorting algorithm is used by this method is not known for us. The public interface, which is a function signature. Function signature in the sense that I know what has to go inside. I should know the return type of the function. I should know the name of the function. I should know the argument type of the function. This is the interface. This is what the programmer knows about this method using this function signature. This is the publicly available, whatever is publicly available, that is a public interface. In the case of private implementation, how it is implemented is immaterial to us. So, in fact, this implementation, the data is also part of the implementation because it could be an array, it could be a linked list. How you are, I mean, you could be, say, for instance, you are actually passing an array list or a linked list or whatever. Internally, how it is handling the data is immaterial for us. All that we need to know is that there is this function signature which is available for us, to which we have to give parameter of this type, and it has this return type. So that is the public interface, the method signature, which is a public interface. Implementation of how it is done internally is private. The programmer or the user do not have to know about it. So this is the abstraction, that is, you are removing the unnecessary details, so that even if you want to say internally, at some point Java decides that okay, there is a better sorting algorithm that has come, which has a a better overall amortized performance as compared to the existing sorting algorithms. Java wants to replace that sorting algorithm. It will very well do without even informing us. In Java 19, it could be a totally different sorting algorithm that it uses, but for us, it's all the same. It doesn't matter at all. I'm going to use a sort method just like I was using it earlier. So even if the implementation changes, the use or the user of the program, whoever sees it, it should not bother them as to what is the internal implementation of that method. So that is the abstraction. You are removing all the unnecessary detailing which is required. You only giving the public interface which is required to be used. This is given by the object-oriented programming. Okay. Now subtyping. Subtyping is, say for instance, you have a subtype A, which is a subtype of, okay, A is a subtype of B. Okay. Now, wherever you want to use B, you can use A. Say for instance, this is easier to remember it this way. Say A is a set and A is a subset of B. This is the same example which I used to give earlier. Say set of even numbers, right? This is a set of whole numbers. Okay. Now, whatever are the properties of B are available for A also. Right? Whatever you can do, the interfaces, that is the addition, subtraction, division, multiplication, whatever are these interfaces, right? That you can actually do it on using even numbers also. So this is about the relationship. So we say that subtyping is more like the relationship of interfaces. What do you mean by relationship? One is a subtype of the other if you know that all that interfaces what are applicable for the parent type are applicable for the child type also, and wherever a parent type is required you can in fact use the child type also. So wherever you are saying, say, I want to find the power of a number, I want to find the log of a number, I want to find the um, uh, you know uh, yeah, modulus, some number mod some number you want to find out. Everywhere you're going to use a whole number, you can use a even number also. The other direction may not be possible, right? So wherever you are expecting a type of B, the bigger type. Here now you can look at it as a bigger type. If you're going to expect whatever is a bigger type, you can use one type of smaller type also. This is a subtype. So we say that this is the relationship of interfaces. So when I come to the inheritance, I'll explain to you how that is different. Now the dynamic lookup, right? So you have, say, variable of type A, and you have a variable B of type B, right? So and A is a subtype of B. Now wherever you have say B. So in Java, let us put it something like this. Okay, B new A. During runtime or dynamically, right? This is the dynamic. During runtime, this variable will have the functionality of A. That is the dynamic lookup. This direction is not possible. Okay, you cannot have a variable of type A taking a variable of type B because B is the parent and B is the main type and A is the subtype. So you can have this kind of a relationship. So you have a variable of type parent type. It can take or it can refer to an object of child type, and during runtime, it can actually be decided as to what is the type runtime type of this variable will be that of A. So if there is a method inside A that has to be invoked, right? So if you simply put something like B and some method inside, so that we will see in the week 2 content. So that, yeah, I think okay. So that will come to that, and when we come to discussing Java. But this is the idea of dynamic lookup. Okay, during runtime, the object of B, the object of the parent type, can actually refer to an object of, or rather, it can point to an object of a child type. That is a dynamic lookup. Okay. Now inheritance, right? Inheritance, what it means that, so you have a parent type and a child type, right? Now you want to reuse the implementations. That is the difference between subtyping and inheritance. Is one is the relationship of interfaces. We call it relationship of interfaces, right? The other one is reuse of implementation. So when you say reuse of implementation, suppose there is an animal which is able to walk, which is able to eat and everything, right? So whatever that animal is doing, say suppose you have a dog, which is the child class of that animal, then you don't have to rewrite whatever the walk method has. You don't have to redefine what walking is. What walking basically means that you are moving the legs. It could be 2 legs, it could be 4 legs. You're actually moving the legs with a certain pattern on the floor. That is the walking. So you are reusing the implementation of walk method which is given in the animal class. So when you look at it from Java perspective, both the subtyping and the inheritance would look the same. The difference that you have to understand is when you say subtyping, you're only focusing more on the interfaces. That is, these public interfaces. These are the capabilities which are available for the parent type, and during runtime, it can actually take a form of the child type. Sorry, that variable can actually take a form of the child type. And these are the capabilities. So what are the capabilities of B? These are the methods which are inside, right? The methods which again are the interfaces, right? So this is the relationship of interfaces. The case of reuse of implementations, as I said, if there is something that you have defined, you're just going to use it, reuse it in here, along with some additional functionalities. You can just, if it's a particular dog, then it can bark, right? So you can have an additional method which is bark, which is not defined for every animal. But the walking, say for instance, if it is defined for every animal, you're just going to reuse the implementation without having to redefine whatever is inside. So in Java, both the subtyping and inheritance are achieved through the extend method, right? Extends keyword. That's why we always have this confusion between what subtyping and inheritance is separately mean. Okay. So that's about the week 1 content. Nalini, you can take over. If anybody has any questions,
Ma'am,
please
like
ask.
subtyping does cannot have additional functionalities.
Sorry,
Subtyping cannot have additional functionalities, right?
subtype cannot have.
Additional functionalities.
It can have no. See, for even number, I told you. In the case of subtype, even number, everything is divisible by 2, right? That's an additional functionality.
Then, like inheritance can also do that.
Yeah, it can do that.
So what's the difference?
No, that's what I told you, right? So that is the confusion that you all have. See, the capability of a class, and whatever the child class has the same capabilities as that of the parent class, right? When I say the when I say the see this one, right? The public interfaces. These are the capabilities. When I say capabilities, these are the methods which are defined. So with respect to Java, these are the methods which are defined inside the class, right? So these are actually accessible from inside the child method. So the child class also has the same capabilities as the parent class. In the case of inheritance, all that you're saying is that the methods are there. Say for instance, you define walk method here, right? That is very much available inside the child class also. So it is again, the interfaces are the same, the capability is the same, but I'm going to focus more on the implementation of that method. Whatever is the implementation of this walk method, which says that I have four legs and I have legs using which I'm going to move onto the ground, right? That is the walking functionality, and that functionality I'm going to reuse in the case of child class as well. So basically, why you are not able to distinguish between the two is that in Java both are achieved through the same thing. Whereas when you say subtyping, it only refers to the capabilities of the interfaces available, right? When there are certain interfaces available, that whatever are available for the parent are available for the child also. In the case of inheritance, you are saying that, okay, my parents have these capabilities, so I am actually going to have those capabilities without having to redefine any of this. You're just going to reuse whatever are the implementations available with the parent. Okay. So you don't have to worry too much about it. If you don't understand this, you can just skip it. That's also fine. Yeah. Nalini, go ahead. Yeah.
Okay, ma'am. Thanks. So yeah, I will share my screen first. So actually, I will just this is summary of week 2 and week 3. I will cover some of the I will cover important concepts here. So first, I will show how to create a class. So basically, class is a template to create objects. So it has instance variables and all the methods that we can that are used to operate on the data which we create inside the class. So yeah, so basically it is a template that has data and methods inside it. So yeah, we can create any class. So let us take some employee class, the same example I am giving, so it will be bit easy to understand for everyone. So employee will basically have name, right? And also let us take age also for now. These are called instance variables of the class. They are generally advised to be private. It is generally recommended to make them as private. So basically, in order to what reduce the number of methods to write, I will just take, okay, let's keep it as private only. So private. These are the instance variables of of this class employee. That means this is the data that we are going to store in the employee class. And there is one, like, we can have class without constructor also. Then compiler will assign default values to this instance variables. So name will be initialized to null and age will be assigned to 0, because that based on the data type they will be assigned. So basically objects will be assigned to null, and int will be assigned to 0, and float and double will be assigned to 0 0.0. So yeah, that's what. So I will just create a constructor. In order to, I want my instance variables to have some values without, like, I don't want it to be default values. When I create object, I wanted to give some name to my object. So how like values to my object, that I can do by using constructor. Okay, so I will assign, so whatever values we pass to the constructor, that values we will assign to the instance variables. So name equal to n and age equal to a. Okay, this is constructor. So you can have n number of constructors in your class. So but the thing is, like, the number of arguments you pass, that should be different. This is called constructor overloading. Like, you can have many constructors, but the constructor number of arguments you pass to the constructors should be different. Like, if there can be one argument constructor, zero argument constructor, or two or three base. But this is This is basically referred as constructor overloading. So the constructor will have same name as your class name, and it will have some access modifier. It is like basically public, we generally keep it as public. And then then the arguments it will take, like whatever the arguments it takes, that we will specify here, and it does not have any return type, so it is called a special method. Because the what what the structure is same as method, no, because it has some name and some arguments and some modifier, but it does not have any return type, so it is called a special method. So constructor overloading also I told, no, you can have n number of constructors in your class. So basically you can have accessor methods and mutator methods. So if your instance variables are private, then you cannot access them outside your class, but sometimes you need to access your instance variables also. So how to access them? By using the methods like accessors and mutators. So accessors basically are used to access your instance variable. That means you can access the name of your object, like name and age of the employee object. If you wanted to change the values of your instance variables, then you can use mutators. They are referred as mutators. Mutators means you can set values to your instance variables, you can update the values of your instance variables. So okay, public. So basically I'm accessing, no. So for accessing, what will be the return type? If you are accessing the name, the return type should be string. So I will say get name, that is accessor. Accessors means we are just accessing, we need to know what is the value of the current employee object. That means you can use this uh, e dot get name or something like that. If you use, then you will get the name of that particular employee. So what we should return? Name. If you're trying, this is accessor for name. And if you want the, and there should be some similar method to access age, you know, access age. So I will return age. These are accessors. This is basic structure of your class I'm explaining. Okay. And you want mutators, no? Mutators generally sets the values to your instance variables. So you are setting, that means you should pass some value to set the value, no, to set the values to your instance variable. So set name, that means I'm setting the name. And setting name means you basically want to set name to your employee object. Then it should take some argument string, and I will say it as n, and I will simply assign name to n, whatever the value we are passing to this n, to this name. Okay. And the return type is void, because we are not what trying to get some value, we are just assigning. So yeah, basically the return type will be void. It is not returning anything, the function is not returning anything. So set age, you can have set age. That means the arguments which you should pass is like int. This is the argument, because age is of type integer, no. So whatever value here I'm passing some integer, so I will assign that value to age. I will say age equal to a, and you can define whatever methods you want inside this employee class. Additional to this methods, accessors, mutators, and constructor, like you can define like whatever methods that you wanted to operate on this employee object, you can define. Okay, this is basic structure. Basically you have instance variables, then constructor is optional, you can have or you may not have. Yeah, if you are not having it, then the compiler will give default constructor. So constructor overloading is possible. That means you can have n number of constructors you are in your class, like 0 argument, 1 argument, 2 argument, or any like that you can have. And you can have some n number of methods in your class. Basically they will operate on the data you, whatever you are providing data you, that means they will basically what modify or act on your instance variables. So that means here accessors, basically accessors, these are the methods that are used to access the instance variables, and mutators, these are the methods which are basically used to set the values to your instance variables. Okay. Okay, how to create objects of your class? Not to create objects of your class, you will just simply write, basically whatever you have done till now is class, that is template to create an object. So employee e1 equal to new employee, that means basically new is the word which is used to create memory. And if you do this, the compiler will give error because we don't have any zero argument constructor in our class. No, whatever we have is like two argument constructor. So you need to pass those two arguments while creating that object. While creating the object, you need to call that constructor. So basically which constructor you have in your class, it is two argument constructor, so you need to provide those two arguments while creating your objects. Okay, this is like this is how you create objects of your class. You can have n number of objects like e1, e2, e3. All all these objects e1, e2, e3 will have separate copies of instance variables. That means memory is separate for e1, e2, e3, so on. Like how many n number of objects you can create, for all those objects there will be separate memory for all these objects. They will have same structure like name and age as instance variable and same methods, but memory is different for these objects. Okay, this is basically how you create objects. So the other topic which I wanted to cover is like copy constructor. If you wanted to create new object, let's take I wanted to create new object employee e2 from e1 using e1. The way I can do is like i can I can have another argument, another constructor with employee object as its argument, and I can simply assign whatever the values the current employee is having to that required employee object. So I will have one more constructor. So this is called copy constructor. Here you are you can, by using this constructor, you can create new object from the existing object. So what you wanted to pass here is another employee, because you wanted to create an employee, new employee object from employee object now. So it takes employee as its argument, and you will assign whatever the object which you wanted to create, its name, to e dot name. E dot name, that means this employee, whatever the employee object we are passing, those two, the value of this we are assigning to the current object. And same thing you can do, this dot age equal to e dot age, that means uh, this whatever the employee you have passed, whatever the employee you have passed, that value you are assigning it to the current value. By this, by using this, you are creating, by using this object e, you are creating new object. Like that means you are setting the values of your new employee to the current employee. So basically these two will have same values. You can later you can modify this also. You can later modify the values of e1 and e2. So if I say e2 dot name equal to Ramesh, and then if I try to print the values, then if I try to print the values of e1 dot name and e2 dot name, can anyone of you tell what will be the values? I have created e2 using e1, then later I have updated e2 name. Will it be same or will it be what different? Anyone
Different.
of,
It will be Rahul and Ramesh. Different.
okay, we can check. Somewhere I have missed the semicolon 34. What? Return age. String. Okay. Its return type is integer basically. Okay, that is private, no? So I cannot directly say this e2 dot set name I have to use. I cannot directly assign values, no, because that is private. Instance variables are private, so I have to use this accessor methods in order to set the values to your instance variables. So I'm calling this method e2.setName.
Same.
God, has private. Okay, you need to get name, you need to use accessor method get name. Basically it will give the get name names of your instance variable.
Same.
So it is like, now you can see Rahul and Ramesh, it is like different, right? Because you have like separate memory is there for e2 e2 also. You have created separate memory for e2 by saying new keyword, and then you have passed e1 to it, no? So basically what happens is that, okay, separate memory is created for e2 by saying new this, and then you are assigning the whatever name, the memory will be there for name and age, you know. So you are basically assigning these values. So if you have some objects inside it, then what will happen, we will check. Okay, let us take it has some string array of projects. String array of projects, if it has that, then this is object, no? This is object. If you simply say here this dot projects is equal to e dot project, I said projects equal to e dot projects, then this time actually this is object. So here you are simply allocating like you are simply assigning it. So basically what object will store here, some memory address, no, here what inside the memory of employee object. So basically for name, age and projects, there will be some what memory will be allocated for these instance variables. But for string array of projects, basically if you assign it to some value, basically for string array of projects you need to give some projects, you know. Here this is objects, object, no, it is an array which is object. String array p equal to some project, I will say p001, and then I will say p002. So I should have three argument constructor as well here. So string array to p. Okay, this is three argument constructor. I have to pass this, right? I'm just trying to print the values of 0. Basically if you have object inside your class as instance variable, then both, like if you directly say if you directly said here, you have directly here assigned in this manner, like this dot project equal to e dot project, that means you are not creating separate memory for this object. Directly you are this both, this current object and this whatever object here e you have passed, both will be pointing to the same memory location, because this will be holding e dot project will be some memory address to this string array. So basically you are assigning this memory address whatever e dot project is currently holding to this dot project. So basically both will be pointing to the same memory location. Even if you change one thing, then the other other thing also, other employee object also will be changed, the value in other employee object also will be changed. So here basically I'm not changing, I'm directly printing. So both of the of both E1 and E2 first project is P001, so that is getting printed. But if I change E2 dot pz project of 0 equal to some P005, and if I try to print this again, then in both cases the project will be updated in both objects E1 and E2. In both of them, the first project will be P005. This is because both are pointing to same memory location. Both the projects array are pointing to the same memory location. We have different memory for E1 and E2, but inside that memory both this this projects, this is object, no, both of them are pointing to the same memory location. So that's why you are getting this same thing. For even if you update one thing, the other thing also is getting updated. So how can you overcome is this is like, you need to create separate memory for this project. So how to create separate memory for this projects? By saying new string array. String, okay, you will first declare some string array. You will first create some string array in order to hold your project. You will first create some memory location for that. This is how basically you create memory, you know. String array, I'm using same length as this projects dot length, e dot project dot length, whatever the length e dot project has, same length I will create. And then I will assign, I will iterate over the current project array string s in e dot projects. I'm iterating over the string array. This is this e will have separate whatever e the employee object you are passing, that will have project now, which is a string array. So you will assign each and every each and like one by one value of this project e dot this employee projects to the new employee projects. So how will you do is like, uh, okay, I need to use for int that thing only, because I should allocate it index by index, no, that's fine. So as this is array, I'm using length, which is instance variable inside your string class, inside your array class. Yeah. So I will assign arr of 0, the current new array which we have created. Start arr of 0 equal to e dot project of 0, which is an array. So whatever the current value I have, I will assign that. And then I will say this dot project equal to arr. So I have created new string array for this project. And what I'm doing is like, inside the newly created string array, for newly created string array, I'm copying each and every value of the this employee, whatever employee we have passed, each and every value, one by one value we are copying from this projects, the string array to the newly created string array. That's all we are doing here. Okay, just will run. I'm just in confusion like whether we need to initialize it to some values or we can directly. Okay, okay. The thing is, what I have done here is like, firstly, previously what we got here is like both are same, P001 and P001, because here we are previously what we have done is like, instead of creating new separate memory for this object, the string array, instead of creating new memory for string array, this is object, no, I have directly assigned it to the existing one. E dot project equal to this dot project I have done, this dot project equal to E dot project I have done. That means both are pointing to the same memory location. In order to avoid that, what I have done here is like, I have created new memory for this project. That means string array I have created, and I have copied each, like, one by one value from this existing project, from this existing this e projects to the current this array, and then I have assigned this array, the newly created array, to our current object projects. So that's why they are not getting changed, the values are not getting changed. This is happening here because this I should comment. Yeah, I think if you have any doubt regarding this copy constructor, you can ask now. Yeah, if not, we'll move to some other topic.
Excuse me, ma'am.
Yeah.
Ma'am, in assigning the
Mhm.
values for each every array, here it should be I, right?
Okay, okay. Yeah, I did it by mistake. Yeah. Sorry, here also it should be I.
I, okay.
Yeah.
Then it will have each and every value.
Value, yeah, each and
Okay.
every value will be
Now,
copied from. Yeah.
yeah, yeah. So, and we can set as per our requirements, right?
Yes, yeah.
Okay.
Yeah, if you have some other object here, you need to do
Mm.
the same processing. If you have some other address object or something, then you
Okay.
need to create new address object here, like
Okay.
same address add, some instance, some reference variable address a equal to new address of, and then you should copy the
Yeah.
values from, yeah, a dot some name equal
Sure.
to street name equal to some, like that you have to do e dots. Yeah, some e dot
Sure.
address dot street name, something like that you have to do if it has some objects inside it. Okay.
Yeah.
Yeah, others please ask if you have any doubt. This is like basic concept from second week, this is main concept actually. Okay. Yeah, then coming to the that's all from week 2 I wanted to cover. Then I will move to week 3 content.
Ma'am,
Yeah.
ma'am, the same process we do using the deep cloning also, right? The same process. If we have the objects, we use
Yeah, that
that.
thing we won't directly create new object there.
Yeah, yeah. I
Then
mean,
we
just
will say
clone.
clone. Yeah.
Yeah, just
Yeah,
with the help of clone
clone
method.
method you will do. Yeah.
Oh,
Yes,
okay.
yeah, basically that is like, if you have nested objects you will do nested cloning there. If you
Yeah.
have nested objects here, you will create new memory for that
Hmm.
object, and then you will assign, then you will
Same.
copy the values from
Yeah, yeah.
there to here. Yeah.
It
Yeah.
will implicitly will do this process.
Yes, yeah.
Okay.
If you say
Thank you.
clone. Yeah, yeah.
Yeah.
Okay.
Thank you, ma'am.
Yeah. Okay, I will remove all these things. Okay, this projects also I will remove in order to just reduce my code. It okay. It's not required. Projects I'm removing, so that's why I'm removing all the other things here. Okay, we'll see whether this works or not. We don't have copy constructor also. I'm just removing all not not required methods. Okay. What is this? Okay, just come remove this. Okay, now it will work. Okay. Okay, now we'll move to week 3. That is like, firstly, I will cover inheritance concept. So basically, you can, so okay, uh, you wanted to create new class. Okay, but you already have some other class that has half of the things you wanted to do in the new class. So how to, so basically you can reuse the your code, whatever you have defined in some other class, you can reuse that code. So how can you do that? By using inheritance. So you wanted to create new class, but whatever you are trying to create, that is already defined in some other class, have like many of the things, or completely, or something like that. If it is, if it has already there somewhere in some other class, then your new class, whatever you wanted to create, that you can inherit like from the parent class, inherit from the class whatever you wanted. So okay, I will, the class manager will have more like all the features of employee class, but he will have some extra additional features. So that's why, in in order to avoid all these things defining everything, I'm just reusing the code. So how to do this? By using this inheritance concept. So basically, manager extends employee. That means manager is child class of this employee. Employee is called parent class, and from the parent class, manager is inheriting the features of, inheriting the features. So okay, so basically the manager will have all the things which are there inside your employee class, except the private things. The private things basically, it it will have, but you won't be able to access inside this class manager, because manager, these are different, no? In, if something is private in your class, that is, that thing you can use only inside your class. Inside the manager you cannot use. Okay, if your instance variables or if your methods are private, then that thing, that instance variables and that methods you cannot use inside the manager class, inside the inherited classes. Okay, now I'm going to define some new instance variable for this manager. Let us take that as salary. Okay, basically everyone will have salary, even employee has salary, but yeah, just here I'm taking this as manager, just as additional feature for this manager. So you want constructor to what, instantiate instance variables of your class. What are the instance variables of your manager class? It has name, age, because these are not private, so it will have name, age, and it has salary also. So you want three argument constructor in order to initialize the instance variables. So string n, int a, and then int s. I'm using this. And then firstly, you know, like I can say here, this dot name equal to n, this dot age equal to a, and this dot salary equal to s, I can say. But you can use the constructor which is provided in the parent class. You can call that by saying super keyword. And how many argument constructor is there in your super class? It's two argument constructor, and that constructor takes string and integer, so you will pass those things. So as, yeah, assignment will happen of those instance variables. So salary equal to this. You are setting values to your instance variables. Okay. Okay, you can have some additional method also here. Uh, public int. I will take integer instead of double. I'm taking integer. Int bonus. Bonus. I am defining bonus. Let us take it as like 10%. Generally, for manager, we are giving 10% bonus. That means, okay, I should return, no? Return salary into 10 by 100. That means, So 10% of salary will be his bonus. So that we are returning. Okay, or else I can just multiply it by 0.1. That also you can do. Into 0.1 also can do. But the return type is should be double, because it is double. Yeah, even you can return integer, then that double value will not be returned. If it is like 150.5, then only 150 will be returned if it is int. Yeah, then if it is double, 150.5 will be returned. Okay. Okay, this is regarding inheritance. Like you can use the features which are already there in some in other class by using this inheritance concept. Okay. And the thing is, like, this employee class reference, like employee e2 equal to new manager, I can say. That means the parent class reference can hold the child class object. This is reference, no? E2 is just reference variable for this employee object. So this the parent class reference can hold the child class object. Actually, which object you are creating here? The child class object, manager object. Parent class reference can be used to hold the child class object. Okay. New manager, and I have to pass three argument constructor, no? I will say Ramesh 20, and salary I will say 10,000. Okay. And then I can use all the methods which are present here. I will say e2 dot get name. That means we should, and I should print it. Then only you will be able to see, no? So this is a method which is there inside your parent class, employee class. This is not there. This method is not there inside the manager class. You are not defining it inside the manager class. It is defined inside this employee class. But still you are able to use it because of this inheritance. And I can call, can I call, can I call this method bonus method using this E2 object?
No, ma'am.
No, you cannot call. This is because the compiler will check whether the bonus method is present inside this employee class. Static checking will happen whether this bonus method is present in the employee class or not. No, it is not there inside the employee class. So you cannot use this inside your what? You cannot use this, but you can just what? Typecast it. E2 object, you need to typecast it to manager. You can typecast it to manager, and you can say bonus. Okay. Okay, we'll see this one, whether this is working or not. Not find symbol E2. No, this is not. Okay, I will just first
Ma'am, this
typecast
bracket
it. Yeah,
will be
yeah, this bracket will be there. Because, so if you do this, yeah, I will explain after getting the output. Okay,
ma'am,
just
this bracket, the opening bracket for A2 should be removed and put in front of a manager. Opening bracket, ma'am.
okay. Okay, let us do in the other way. This is confusing for many of us also, right? So I will just typecast it here, there itself. E2 I have, no, so I will typecast it here itself to manager. Manager spelling is correct only, no? Okay, okay, let me check here. Manager m equal to new manager, then I will say m dot bonus. So actually E2 is of type employee. Then I will typecast it back to manager. That is some manager, no? The now it will be some manager, no? So I'm assigning it to M, and then I'm calling bonus method from this M. So yeah, yes, other yeah. Can you please repeat like how you wanted to do? Actually, yeah, bracket thing.
Ma'am, this double bracket manager,
Okay, just let me write manager.
ma'am, double opening parenthesis before manager.
Okay, okay. Two openings. Yeah.
Uh,
Okay.
and
Yeah.
then
One
closing
closing. Yeah.
A2
E2. Okay.
closing.
Yeah. Yeah. Okay. So yeah, this is because E2 we are typecasting it back to manager, so that will be manager. From that manager object, we should call bonus method. So whatever the return, this will be some manager object, no? So from that manager object, you have to call bonus method. If you remove this, then you are directly calling it from E2 dot bonus. For that, you are typecasting it, no? If I remove this, but this extra bracket is required. But if this is confusing, this extra brackets thing, you can just do this. E2 you have, you will typecast it to manager, the manager, no? So that will be some manager. You need to assign whatever this object which we get to some manager object, and from that manager object you can call bonus method. That thing you can do. So actually E2 here E2 is employee type. Here you are using get name method, which is present in employee class. That is not there in the manager, but you are still reusing. That is because of inheritance. And if you wanted to use additional feature, if you are using employee as type reference for your this child class object, then this kind of typecasting you should do. But you can basically you can do manager m equal to new manager. You can just give manager reference, and you can call the manage m dot get name. That thing also you can do. I will show that also. So instead of making making parent class reference, you can make child class reference, and and then you can call m dot get name and m dot bonus also you can do. So this also works. This also will work because inside the manager class you have bonus, so that will also can be taken directly. Okay, this is inheritance. And okay, method overriding, method overloading is also there. So if some if some method which is there inside the employee class. Okay, let us take some method. Can you suggest me any method for employee class?
Um, Same bonus method, ma'am.
Okay, but he doesn't have salary.
Um,
Okay, I will
okay.
just create. I will just create. Some print method I will display method I will say. So that will display the
Okay.
details. Yeah. Oh, this yeah. Okay. Okay. So actually you have this display method inside employee class, but but for manager there is other instance variable also, like salary also it has. So you wanted to display all three details of your manager. Then how can you do is like you can override the method which is present inside your parent class. So basically you can say public void display. You can override, that means you can define new display method for your manager. So you are here, you are defining new display method. So basically it has employee has this employee has display and manager also has display. But the thing is everything is same here. See, return type and also number of arguments it takes and the method name is same. That means for method overriding, the method should have same, what, same structure, like return type, name, and this brackets like arguments it takes, that should be same. And the modifiers, like if it is private, if it is some protected inside your child class, you can make it as public inside your, see, not, sorry, if it is private inside your parent class, you can make it as public inside your child class. So you can increase the visibility, you can increase the visibility inside your child class, that you can do while overriding. Okay, if it is protected, you can make it as public inside your child class. Okay, is it clear?
Ma'am, I think for protected we can do, for private can we do?
Yeah, private you can do. Let us make this also as private, then that display won't be visible at all. That means this is kind of new method only, no?
Yeah,
Yeah. Okay, even if that is private, this display won't be visible to manager, but manager
man.
can display, yeah, its own private display method. Okay,
Manager will have
its own
his
display,
own method.
yeah, its own method. Yeah, you access in what increasing the visibility is possible. Okay.
Yeah. Okay.
Yeah, other thing, if your method throws some exception inside your parent class, that same exception should be thrown in the child class also. Let us take
Okay.
example of clone method. Here clone inside the object class, it will throw clone not supported exception. So while defining also your clone method, you will throw that same exception, no? The same thing, that exception you should throw that should be done as it is, but this visibility you can increase from
Okay.
parent class to child class. Okay.
Okay.
Yeah.
For protected also, yeah, for protected we can increase public by extending. Yeah. Okay.
Yeah. Yeah. Okay. That okay. If here you have, let us take some same thing. I will dynamic dispatch. I will show new manager. Uh, Ram, and his age is 25. His salary, it's, let us take 12,000. Sorry. Actually, display method, if it is private, then you cannot see, then there won't be any confusion, no? If it is private, then there won't be any confusion. Display method I will call. Yeah, if it is private, e2 dot display definitely will call the display
From
method of
manager.
manager.
Yeah.
Okay, I will remove this as private, I will make it as public. Okay. Okay, now if you call display method using e2, if you call display method using e2, so which method will be called? Either display method from employee or it's, or from manager will it be called? The
From manager, ma'am.
yeah, from manager it will be called. How it will happen? Basically first checking will happen whether e2 has this employee has display method or not. yes, it has display method. If it does not have display method, then the compiler will give compile time error, no display method, something like that. You need to typecast, and then you should call display method. If display method is not there inside your employee class, it is there inside the employee class and inside the manager class. But here static checking will happen whether display method is there for employee. Yes, it is there. Then while actually invoking the method based on the object, it is like manager object we are creating, no, manager object we are assigning it to e2. Based on this object, that particular display method will be called. Here manager display method will be called, not employee display method is called, because the object which we are creating is manager. Just e2 is reference, just reference, like you will have reference variable, no, int x is a reference variable, so e2 is reference. But the memory you have actually is manager memory. So while actually getting, when we invoke this method, actually display method will be invoked from manager and the details will be printed. This is called dynamic dispatch. And ma'am also previously told, no, what is dynamic lookup. That means you can assign child class reference, not parent class reference, to child class object. Okay, this is void.
Yeah, Nalini, you should write outside of
Yeah, this is void.
stem.out.
Yeah. Okay, now actually display method of manager has got printed because it is returning name, age and salary. Okay, overloading is means you can have same method with different arguments, different number of arguments, different number, different type of arguments. Yeah, that thing is called overloading. Let us take example of bonus only, bonus, to explain this overloading concept. So return type you cannot change. If you change the return type, I will check here int bonus, then it will give error. Return type you cannot change and you cannot have new overloaded method. If I say return 100 here, and if I call bonus method, m dot, I will say m dot bonus. I'm calling bonus. Yeah, mostly it will give compiler error because there are two bonus method. By seeing this, it cannot figure out actually which bonus method we are calling, because already see what we are passing, we are telling bonus, simply bonus, no, where the both bonus method has zero arguments. So how it will figure out which bonus we are actually calling? So even the return type is different, while invoking it doesn't know which bonus method we are calling. So in order to make it work, you need to have some argument here, int x something and return x. So then you can pass here some 100, then it will, I need to enclose in print statement in order to print that. If you just change the return type of your method and if you wanted to achieve overloading, then it cannot achieve. But you need to either change the number of arguments or type of argument, then by yeah, you can change the return type also. But along with the return type, you have to change this number of arguments in order to achieve overloading. But yeah, here by keeping the return type same, and by changing the number of arguments, by changing this arguments also, you can achieve the overloading. by changing the return type alone, you cannot achieve overloading. You should either change the number of arguments or type of arguments, then you can achieve overloading by changing the return type as well. Okay, and basically how to achieve the overloading, your method name should be same as your name, as the same name, both the methods should have the same name, and here the number of arguments are different. You can have some like this also, void string x, something like that. Okay, string x some, then you can give return string. So that means, so in order to figure out, like the compiler should figure out know how to, which method you are calling. So based on the number and the type of arguments, compiler basically decides which method you are calling. So yeah, so that means you can have the same method with the same names, but by changing the type of arguments and the number of arguments, you can achieve the overloading. Okay, is this clear?
Yes, ma'am.
Yeah, okay. Okay, this is overloading. Yeah, any other things from week 3? Just overloading, overriding, polymorphism, inheritance, dynamic dispatch. Actually, I wanted to tell what is the use of this dynamic dispatch. Basically, like parent class reference can hold child class object, no? So if you have same thing, developer, that also is extending manager, or or okay, developer extends manager, let us take some new method should be there for developer. Okay, he will have some team. It is not necessary to have new instance variable, I will have same. Okay, but in order to change this display method into team size, okay, it will print name, age, salary and team size of the developer. And you want constructor. Okay, I should have 3 argument constructor, or 3 or 4, yeah. Yes, a super of n comma a comma, yes. So actually we are calling here manager class constructor. Inside the manager class constructor, employee class constructor will be called, and thus, and this is how instance variables will be assigned. Okay, that's all. Okay, I will create one employee. This is basically regarding how, why, actually what is the use of this this dynamic lookup, why we need, why, what is the use of holding this parent class reference can hold child class objects, what is the use basically. So I can have new manager, new employee. Achha, all these are getting copied. I have created an employee array, and I've just filling my array with this objects. This is developer. Team size, no, 4. I will give. Okay, that's all. My employee array is finished. Okay, I will just comment all these things. I will define one more method here. Something. Public void, some method name. Okay, function one, something like that. It takes employee array E, and it will call display method for this array for each and every object inside the employee array. For int I equal to 0, I less than e dot length, employee array length. I'm iterating over the length of the employees over this array, and then I'm calling display method for each and every object. E of 0, e of I dot display. Oh God. Yeah, I'm calling display method. Now I will invoke this method. This should be static in order to call it directly from the main method, because main is static, so you can call only static methods without using object uh, in the static methods can be called in the static blocks, no. So here you will say one of E. You will pass this employee array E, whatever you have created. Okay, then all these things will be printed. Details of Rahul 23, Ram 25, all these things. What is the advantage here? You are using single reference, no employee reference. Here you are using single employee reference, and you are storing all these child classes, and based on the object you are storing, that particular display method is being invoked. So you can use instead of instead of defining your method like manage, instead of taking your method 3 arguments like employee, manager and developer, like 3 arguments, employee object and manager object and developer object, you are directly giving employee array. And based on the object here this is employee object and this is manager object and this is developer object, based on the object the particular method will be invoked. The advantage here is you can use single reference variable, single, right, employee. So this is basically, so why do we need this feature? Instead of this employee e2 equal to new manager, you can simply say manager m equal to new manager and you can simply invoke. But in order to achieve this kind of thing, like you can use single employee array and you can store different types of object, different type of employee object, and you can invoke their respective methods, no. So that's why this is one of the advantage by making uh, making child class reference to hold parent class reference to hold child class objects. Okay, is it clear? Hello.
Yes, ma'am.
Yeah. Okay, that's all I think from week 3. Some access modifiers are there. Yeah, that will be anyhow covered in packages or packages, that thing, no, like package week, that is week 7. Yeah. Okay, that's all from my side. Yeah, I think answer you can continue.
Okay. Thanks, Nalini. I hope my screen visible, right?
Yes, sir.
Yeah. Okay. Now let me discuss about week 4. Yeah. So first topic in week 4 is abstract classes. Okay. So what is the use of abstract classes? Okay. So what is abstract first? Abstract is nothing but,
Which doesn't have proper implementation.
yeah, so simply incomplete. Okay, we can
Yes,
say incomplete. Okay.
yeah.
So what is the purpose of abstract classes? Okay. See here, sometimes we collect classes together under a common heading. Okay. So when to collect, okay, these classes together, some classes together. See here we have, okay, four classes here, sorry, three classes here. So Swiggy, Zomato, and Food Panda. Okay. So these three classes are used to order the food. Okay. So here Swiggy, Zomato, okay, Food Panda. So here person is a class. Okay. It is going to, okay, order the food from either Swiggy, Zomato, or Food Panda. Okay. So person is, okay, person should call food order method in order to get food from, okay, from either of these three classes. Okay. So either Swiggy or Zomato or Food Panda. Okay. So here in main method, so here we are going to create an object for person. Okay. And we are going to call food order method. Okay. Here food, if you see the definition of food order, okay, so here we have parameter what, Zomato. Okay. So Zomato, so here we are able to pass what, only Zomato object. Okay. Zomato object. Now what happened here, this new Zomato object is passed to this parameter. Now Zomato is initialized with the Zomato object, and it is going to call what, Zomato order method. Okay. Now you will get, you ordered from what, Zomato. Okay. For suppose if you want to get food from Food Panda, where you have to change, this is the first place, this is the second line, and this is a third line. Am I correct?
Yes, sir.
Yeah, these three lines you have to change. Okay. So every time you have to change these three. Okay. Now what I'm doing is, instead of, okay, changing like this, I'm going to collect these three classes under a common heading. Okay, that is, that common heading is food order. Okay, so here food order is, okay, a class. Okay, so now I'm forcing every class, okay, every class to extend this food order class. Okay, so this food order class given one method, that is order. Okay, so here you can order food. Okay, but here this is, okay, a method given by the food order method. Okay, here we are forcing every class to, okay, what, extend the food order. Okay, so this is normal class. Okay, and this is normal method. So it has, this is concrete class and this is concrete method. Okay, yeah, now here every subclass has its own method. Okay, its own method. Now here what I am doing is, instead of, okay, instead of taking what, particular subclass as parameter, I am taking food order class as parameter. Okay, so Nalini ma'am already told, no. Okay, so here I am taking food order class as parameter. Now, okay, now this food order class is base class of all these classes. Now you can pass any of this child class reference to this order. Am I correct?
Yes, sir.
Yes, sir.
Now, yeah, here you no need to change anything. Okay, here you no need to change anything. Okay, yeah, here, okay, you can pass any object here. Okay, here you should change every time. Okay, here you should change every time. But if you call directly order dot, okay, okay, something, so you cannot call, okay, you cannot say which object it contains, right? Which object
Yes.
it contains. So here you have to check, okay, this order contains whether it is instance of Food Panda or Swiggy or Zomato. Okay, you should check, and according to that you should call appropriate method from, okay, respective class. Okay, yeah, now here, Okay, for suppose here this food order class has 100 methods, then you have to write 100 what? Okay,
Checking the
100,
instance of.
yeah, checking instances, right? Yeah. So in order to, okay, here the problem with these methods, right? Swiggy order, Zomato order, and food order. Okay, because every subclass using its own, okay, food order method. Okay, so now I don't want to do like this. I want to force every my subclass to override this method. Okay, override this method. Yeah, now what I'm doing is instead of giving the implementation, okay, instead of giving this implementation, what I'm doing is I'm making it as abstract. I'm making it as abstract. Okay, so if your class has at least one abstract method, then your class become abstract. Okay, yeah, see next slide here. Yeah, now here this order method, okay, I given as empty. So if your class has at least one abstract method, your class also should become abstract. Okay, now so if you extend any abstract class, okay, first you should override whatever the abstract methods in the, okay, abstract class. Okay, here food order is what? Okay, parent class of Swiggy. So here food order is what? Abstract class. It has one abstract method. Okay, now you need to override. You should provide implementation for this abstract method. Otherwise, your class also become abstracted. Okay, yeah. See, order. Okay, it has its own implementation. You ordered from Swiggy and Zomato. Okay, here Zomato also. Okay, overridden what? Same method order, but the implementation is different. Here also method is same, but implementation is different. Okay, yeah. Now you no need to check anything here. This is what dynamic method dispatch, right? This is dynamic method dispatch. Okay, here you no need to change anything. Here also you no need to change anything. Here you have to change, okay, from which, okay, from which class you want to order the food. Here you need to change every time. For suppose I want to get food from Food Panda, so now I'm passing here Food Panda. Now what happened? Okay, this order with initialized with what? Food Panda. Now if you call order dot order, now you tell me order method is called from which class?
From food orders. Oh, sorry.
Food Panda.
Oh, yeah. Sorry, food part. Yeah.
There is no conflict, right? Because
Yeah.
every child class has same method. But based on the, okay, runtime initialization of the object, it is going to call appropriate method from the appropriate class. Right? Sorry. It is going to call order method from the appropriate class. Okay, based on the runtime initialization of the object, it is going to call order method from the appropriate class. Is it clear?
Yes, sir.
Yeah, you can pass any class object here, any child class object. Okay, you can also pass Zomato also, new Zomato. What happened? This order is initialized with Zomato.
Zomato.
Yeah, now if order dot order means it is directly it is going to call order
Zomato.
method from Zomato.
Zomato plus.
Okay, now there is no what instance checking here.
Yes.
Okay, so this is the usage of abstract methods and abstract classes. Is it clear for everyone?
Yes, sir.
Yes, sir.
Yeah, interfaces. Yeah, abstract classes. Okay, so actually in abstract classes we can also write concrete methods. Okay, you can also write concrete methods, but interface is purely abstract. Actually up to Java 1.7, up to Java 1.7 version, okay, this interface is purely abstract. Okay, you should not write other than abstract methods in the interface. But after, okay, so from Java 1.8 onwards, okay, interface is extended to allow static and default methods also. Okay, yeah, here all methods are abstract by default in the interface. Okay, for suppose, okay, if you define interface, okay, interface, okay, I, okay, interface I for suppose, okay. So here what I'm doing is void, okay, void add one method, okay. I put semicolon because by default, okay, all methods are abstract, okay. Here you no need to add public and abstract before the abstract method in the interface, okay. Public abstract, okay, automatically your compiler will add, okay, your compiler will add what, public abstract before the abstract method in interface, okay. You no need to worry about these two things, okay, public and abstract before the abstract method in interface. But if it is abstract class, okay, if it is abstract class, for suppose abstract class A, if you write void add semicolon, your compiler will generate compile time error. Why? Because you should mention abstract keyword explicitly before the, okay, method signature, okay. So if it is interface, okay, your compiler automatically will add public abstract, okay, to the abstract method, okay. Yeah, next, if you want to if you want to declare any variable in an interface, okay, that should be final, okay. So your, okay, your interface must contain what, final variables only, okay. You cannot okay, declare normal variables, okay. For suppose here you declared a variable into a like this, okay, your compiler will generate an error at compile time. Why? Because, okay, here every variable in an interface by default public static final, okay, public static final, okay, public static final, okay, int a. So automatically your compiler will add public static final before the what, variable, okay. That's why you should initialize variable, okay, in the interface, okay. If you try to declare a variable, okay, without initialization, okay, definitely your compiler will generate compile time error, okay. So automatically this public static final will be added to the what, variable, okay. For suppose you declared a variable, okay, you declared a variable int, okay, x is equal to 10, okay, it is okay, okay. Automatically public static final will be added by the compiler at compile time, okay. Is it okay?
Yes, sir.
Yeah, so we have programs given in the slides. Yeah, see here, interface A and interface B. See here, int A is equal to 10, okay. Here I have not added anything, okay, public static final before the variable. And here also method void show I given semicolon, okay, there is no public abstract, so there is no compile time error, okay. This is directly copied from uh, Eclipse. So if you have any compile time error, then definitely there will be a red mark, right? Okay, so there is no red mark. Yeah. Now see in interface B, so I have added explicitly public static final before variable declaration. Okay, so there is no different. If you forget to add this public static final, okay, before variable, okay, so automatically your compiler will take care about it. Okay, this is only for interface, okay. Yeah, now see here, yeah, here interface A and interface B, okay. So your class cannot extend more than one class, okay. In inheritance, okay, multiple inheritance is not possible at class level, but at interface level, okay, you can implement more than one interface, okay. You can implement more than one interface. So whenever you implement any interface, okay, any interface, so you should override whatever the abstract methods present in that interface, okay. Here your class impl is implemented from class A and class B, okay. Here class A has one abstract method, void show, and a class B has one abstract method display, void display. Now your class IMPL should override, okay, these two methods. Okay, these two methods. For suppose you override only show method, you forget to override display, then your compiler will generate compile time error. By because here you should override this method. Otherwise, you can make it as abstract. Okay, if you make this class as abstract, no problem. But your class is concrete, and you forget to override this display method from class interface B, then definitely your compiler will generate compile time error. Okay, so here whenever you implement any interface, okay, first you should override whatever the abstract methods present in the interface. Okay, yeah, I hope this is clear, right?
Yes, sir.
Yeah, so already I told no, up to Java 1.7, okay, Java 1.7 interface is purely abstract. Yeah, Mehak.
So, like in interface, we can have default and static complete methods. So, do we need to override those methods as well in the child class?
Concrete methods means only default and static methods. You no need to provide implementation for default and static methods.
Okay.
Okay, so if you want to use the default method as it is, you can use. If you want to override, you can also override, but it not forcing you to override default and static methods.
Okay.
Okay, only you should override abstract methods. See here, yeah, I will explain in this slide. Here, default static, sorry, default void display. Okay, so this is a default method. Okay, this is default method, and this is static method. Okay, so this is interface A, and this is interface B. Okay, so as of now, okay, okay, see here, for suppose there is no interface B, only interface A is there. Okay, now your class is implemented from, okay, interface A, for suppose. Now here your class IMPL, okay, here your interface A is not forcing this IMPL class to override this display or show. Okay, already I told no, if interface has any abstract method, then only your class should override those abstract methods. But there is no abstract methods, right? There is no abstract methods. So now, okay, now you no need to override anything here. Okay, yeah, now here we have one more use case. So that is, for suppose your class is implemented from two interfaces, A and B. Now here interface A and interface B, there is no relationship between interface A and interface B, but these two are implemented from class IMPL. Now these two classes has, okay, these two classes has same default method, that is display. Okay, same default method, that is display. Now here IMPL class, okay, IMPL class not overridden this display method. Now if you create an object for IMPL, and if you are trying to call obj.display, okay, so please remember that there is no display method here as of now. Okay, there is no display method in the IMPL class. Okay, now if you call obj.display, what happened?
It will get confused, sir. Compiler will get confused from which interface it has to call.
Yeah, because here IMPL is implemented from interface A as well interface B. Both interfaces has same default method display. Now compiler will get confused, right? So that's why, okay, that's why. So if you implement, okay, two interfaces and both interfaces has same default method, then you should provide fresh implementation for that method. Okay, fresh implementation for the default method. Okay, this
Sir,
is also
what
for,
about static method? Will it also get affected?
no, there is no confusion. Why? Because Here, this is static, right? This is static, right?
Yeah, yeah.
Yeah, static, right? Here you no need to create an object. Actually, directly you can call a dot show and b dot show. Why? Because this is static, no? So you can call directly using the class name or interface name, as it is static. In your class also, if it is static, you can call by directly by using its class name, right? So here also, if it is static, why to create the object here? You can call directly by using interface name. So that's why there is no confusion in static method point of view. Okay, so this is default method. So default method you cannot call directly by using class reference or class name or interface name. Okay, you should create an object, okay, in order to call these default methods. Okay, that's why we are creating an object of what, implemented a class impl, and we are calling display method. So if this display method is present in both interfaces, then there is a confusion from which class, from which interface it has to call. So in this case, here impl class should provide fresh implementation for this display method. This is only for default case, default method, because there is no confusion between for static only. Okay, if it is display method, sorry, only if it is default method, then only you need to override. Now for suppose here we have print method. Now you tell me, is there any confusion?
No, sir.
Is there any there is no confusion. Why? Because here there is no display method overridden here. Okay, now you created an object for impl and you are calling obj.display. Now you tell me from which interface it is going to call.
Interface B, sir.
Interface b. Why? Because it is available in the, okay, only available in the interface b.
Interface B.
First it will check in its own class. If it is not there, it is going to approach, okay, interface a or b. Okay, here it is there, so it is going to call from interface b. For suppose here display method is present in both the interfaces, then there is a confusion, right? So in this case,
Yes.
you should override this default. Is it clear?
Yes, sir.
Yeah. Sanjay?
Yes, sir.
Okay, so I hope this interface are clear, right? Should I move to next topic?
Yes, sir.
Yeah, private class. Okay, so here, see, so in your class you can declare, okay, you can declare variables, right? You can declare variables. So these are what, members of your class. Okay, members of your class. So this is what, okay, normal variable. This is reference variable. Am I correct? Because this is, okay, not normal variable, this is a reference variable. Okay, so you can initialize this payment with what, payment class object. Okay, this is a reference variable. Okay, so here how you are declaring variables, you can also declare a class as, okay, member of another class. Okay, you can also declare a class as member of another class. Did you get my point?
Yes, sir.
Yeah, so here you can make it as private, right? You can make it as private, right?
Oh, private payment.
Yeah,
If it is.
private string user, private
Yeah.
indicates private. Yeah, you can make, right? Same.
Yes, sir.
Okay, so same for inner class. Okay, same for inner class. Also you can make it as private. Okay, so here why to, okay, make a class as member of another class, and why to make it as private. Okay, okay, why a class, okay, need to declare a member of another class. Okay, and why to make it as private. Okay, yeah. Now see here. Here my class is book my show. Okay, so it has some instance variables. So these are the instance variables. Okay, string user, tickets, payment. Okay, yeah. Now here user means either user email or phone number, something. Okay, we'll take it, and a number of tickets. And here payment, actually, so here payment is the final stage. So once payment is okay, then only, so we should tell them, okay, your tickets has booked, right? So without payment you cannot okay, give the tickets, right?
Yes, sir.
Yeah. Now here payment is a class. Okay, payment is a class. It has some sensitive information, right? See here,
Hmm.
card number, CVV.
See.
Yeah, this is some sensitive information. And this book my show, okay, book my show is depends on the payment class. Okay, so payment class. Now this sensitive information, okay, so if you declare outside of this book my show, now other classes also, okay, other classes also can access this payment method. Okay, so outside you cannot declare this class as private. Okay, this is not allowed. Okay, this is not allowed. Okay, you cannot make, okay, so outer class as private, this is not allowed. Okay, but if you declare this class as member of another class, then you can make it as private. Okay, now, yeah, did you get my point? So
Yes, sir.
outer class cannot be private, but if you declare it as member of another class, then you can make it as private. But why? Because here now your class is member of another class. So
Hmm.
member of your class, you can make it as private, right? So here this is member of what? Book my show class.
Book my
This
show.
is member of, yeah, you can make member of a class as private. Now you are making this private, sorry, this payment class as member of book my show class. Now you can make it as private. Okay, outer class cannot be private, but if you declare a member, if you declare a class as member of another class, then you can make it as private. Okay, inner class can be private. Okay, inner class can be private. Yeah, now see here, for suppose this is book my show. Okay, book my show. So here this book my show has book ticket method. Okay, now here payment, okay, already I told, no, here book my show is depends on the payment class in order to confirm the payment by the user. So if payment is success, then only tickets gets booked, right? Okay, here we are going to check whether payment is success or not. Okay, based on that we are going to confirm the tickets. Okay, yeah, here if it is outside of, okay, book my show class, it is visible to other classes also. See here, user ticket is a class. It is also, okay, creating an object of payment and calling make payment method, right? See here, not only book my show class, here user ticket class also directly calling payment. So it has some sensitive information, right?
Yes, sir.
So there may be a chance of misuse. Okay, there may be chance of misuse. That's why what I'm doing is, so I want to use this payment class only by the book my show. Okay, only by the book my show, and I don't want to visible this payment class outside to any other class. Okay, what I'm doing is simply, okay, simply, okay, see, I'm moving, okay, this class as member of what, book my show class. See, is it clear? So
Yes,
here,
sir.
yeah, now this payment is member of which class?
Book
Book
my
my
shows.
show class. Okay, book my show class, and I'm making it as private. Why? Because now this class is member of book my show class. Now if you try to create an object of payment, okay, directly.
Okay.
Okay, so you will get compile time error. Okay, your compiler will tell, okay, so cannot find symbol this payment. Okay, because it is private, right?
Hmm.
That's it. So I hope it is clear, right?
So, sir, here we are making the payment as a member, and we are making it as a private
Yes, yes. Now only, now this payment class only used by book
book
my
my
shop.
shop.
No other can no other class can access this payment method directly now.
Okay, sir, and payment method is can access these variables, right? User mail, movie name,
Hmm.
amount.
Yes, yes, yes. This
Okay,
outer class,
is
okay. So
uh,
these variables can be accessed by payment also.
yeah, but these variables, card number, CVV, are mm,
Yeah, yeah, I got your point. So
yeah,
whether these private members of inner class are accessed by book my show class or not,
sure,
that is your
yeah,
doubt, right?
yes,
Yeah,
sir.
you can access. Why? Because it is this class is in the
It's a
scope of book my show class,
book
right?
my shop. Okay,
Yeah.
okay,
Now your outer class can access private members of your inner class.
okay.
It is
Both the way the
possible.
access is possible.
Possible, yes.
Okay, sir.
Yeah. Now next slide. Interaction with state. Yeah. See. Yeah. See here. Class student. So it has three instance variables: roll number, name, and age. Okay. So here three mutator methods and three accessor methods are required. Okay, so in order to update and access the, okay, what instance variables of student. Okay, here for suppose I have 60 objects. I created 60 objects for for suppose there are 60 students in the class. So I need to create 60 objects in order to update the details of students, all students. Okay, now you tell me. Okay, now you tell me how many number of methods, okay, you need to call in order to update the, okay, details of each student.
Uh, for each and every object, there are three
Hmm.
methods and three. Okay,
Yeah.
six. Okay,
So 60 into 6.
6. Okay, three mutate. Okay, update only three. Okay,
Yeah. Set roll number, set name, set age. Right? So here three mutator methods for each object you have to call in order to update the roll number, name, and age. Right? Now you tell me. So in order to access, okay, access the details, you need to call three accessor methods, right? Again,
hmm.
you have to call 60
60
into
and 53.
180. Total 360 times you have to call the methods and method calls.
Yeah.
Okay. So method calls are 360 are required, right? 360 methods are required. So method calls are required in order to what? Okay, let me so for suppose, in order to update the details of each student, 180 function calls are required. Okay. Yeah. Now what I'm doing is, in order to overcome that, so simply what I'm doing is, here I'm going to take public void set student. Here I'm updating object as a whole. Okay, I'm updating object as a whole. Okay, so instead of, okay, updating, okay, instead of updating each and every property of the student, so simply I'm updating object as a whole. Okay, so here string roll number, string name, and int age. So in this method you can write like this dot roll number is equal to roll number, this dot name is equal to name, and this dot age is equal to age. Now you tell me, in order to update, okay, 60 students, okay, 60 students data, now you tell me how many function calls are required.
60s.
Into one, right? Only
Yeah.
one. Is it clear?
Yes, sir.
Okay, next one, Java callback methods. Okay, what is callback actually?
Uh, so whenever in a function we call another function, it will come back again to the which called that method.
Yeah, so here callback method. Okay, so it is happened when particular event is happened, right?
Yeah.
Okay, so here that whenever that particular event is happened, so first we are going to, okay, call the timer. Okay, so
Okay.
timer will decide. Okay, so timer will decide, okay, which callback method has to call. Okay, based on the condition, it is going to, okay, call what particular callback method from, okay, particular class. Okay, so here we are going to call the timer, and timer will call back the appropriate callback method from appropriate class. Okay, so based on the, okay, but we are going to write particular condition. Based on that condition, it will call back. So we are calling the timer, timer will call back the callback method. Okay, see here, I want to know whether today is working day or weekend. Okay, so here notification, here I defined one interface with the name notification. It has one method, void notification. Now I am forcing working day and weekend, these two classes, okay, to implement this notification method. Okay, now this working day and weekend both will override this notification method. Okay, notification method, and provide some implementation. Okay, now here we no need to call this notification method. Okay, notification method from either working day or weekend, we no need to call. Okay, who will call this notification method from either working day or weekend? Who will call?
Yeah. Timers.
Yeah, so timer will decide. Okay, so what we are going to do is, here we are going to, okay, start the timer. Okay, we are creating an object of timer, and we are calling the timer. So for timer, okay, while, okay, during calling this timer, okay, we are passing date as parameter, data object as parameter. Why? Because here timer will decide based on the date, based on the day. Okay, it is going to decide, okay, from which, okay, from which class, okay, notification method should call. See here, here timer dot start, what you are passing here, data object. Okay, now this data object contains, okay, this data object contains, okay, which day it is. Okay, so here which day it is. Okay, here day will return as integer value, 0, 1, 2, 3, okay, 4, 5, 6. These are the written values, okay, of day. Okay, so 0 indicates Sunday. Okay, Sunday. Okay, 1 indicates Monday. Okay, 2 indicates Tuesday. Okay, 3 indicates Wednesday, and 4 indicates what, Thursday, and this one is Friday and Saturday. Okay, now you tell me. Okay, so when notification method should call from working day?
When from 1 to 5, it should call from working day, sir.
When notification method should call from weekend?
0 or 6, sir.
0 or 6. Okay, so here timer simply will write a condition, if day is equal to 0 or 6,
6.
then notification method should call from
Weekend.
weekend. Otherwise else
Working day.
working day, right? So here I have callbacks, right? Yeah. See, so here interface, notification, So here working day and a weekend, these two are implemented from notification interface. So both provides what implementation for notification method. Okay, so here the implementation is today is working day, please stay on your work. So here the implementation is today weekend, enjoy the day. See here, just we are starting the timer. Okay, we are just starting the timer and passing date object as parameter. Okay, now your timer, okay, your timer, okay, so this is reference variable, okay, notification. So public void start. Here we have what, date object. Okay, now we are going to get which day it is. Okay, by calling getDay method. So here date dot getDay. Okay, if it is 6 or 0, 6 means Saturday,
Saturday,
0 means
Sunday,
Sunday. If it is Sunday or Saturday, okay, if it is Saturday or Sunday, then you should call notification method from
weekend,
weekend. Okay, else means whether it is 1
1
or
to
2 or 3 or 4 or
up to
5.
12. Yeah,
Okay, then should call notification method from
working day.
working day. Okay, so see here, now you tell me, if I execute this program, which notification method will call, working day or weekend?
Uh, Today's, yeah, working days.
See, today is working day, please stay on your work. Now I don't change anything in this program. So if I execute this program on Saturday, now you tell me.
It will be from weekend.
Okay, definitely it will from
Weekend.
weekend. Okay, so based on the particular condition, based on the particular event, it is going to call what, a particular callback method. So here callback, you no need to call callback method directly. So just you are going to, okay, call the timer, and timer will call the callback method based on particular condition. Is it clear?
Yes, sir.
Yeah. Okay, already we have. Yeah. So what is iterator? What is the use of iterator?
It will run through the it yeah, yeah, it will run through the elements.
Yeah. So here iterator is used to, okay, is used to loop through any data structure. Okay. So for suppose there is a list. Okay. So your list contain some values. Okay. So like 100, okay, 200, okay, 300, like this. Your, okay, list has what? 3 elements like this. Okay. It can be any data structure. So now iterator is going to traverse through your data structure, and it is going to, okay, it is going to visit each element, and it will return the elements from any data structure. Okay, from any data structure you can loop through any data structure by using iterator. Okay, iterator is used to loop through any data structure. Okay, so it is going to visit, okay, it is going to visit each and every element, and you can get an element by using iterator. Okay, now see, this is a custom iterator actually. So we have predefined iterator also. So we'll discuss predefined iterator in week 6. So this is what a custom iterator explained by the sir in the lecture. So for suppose your list contain elements like this, 300, 200 and 100. Okay, so this is the first element, second element and third element. Okay, now, so here, actually here iterator is an interface. Okay, so this interface has one implemented class. Okay, so here iterator, okay, iterator it is equal to, okay, is equal to implemented class object. Actually here we can initialize it with the implemented class object. Why? Because here iterator, here iterator is interface. You cannot instantiate directly, right? So iterator, so you cannot instantiate what interface directly. Okay, you cannot create an object of iterator directly. So here get next and what has next, these two are abstract methods. Okay, these are implemented by some class. Okay, iterator has some implemented class. Now you can initialize this iterator it with its implemented class object. Okay, now you can call this has next method and get next method in order to get elements from any data structure. Okay, you can get elements from any data structure by using iterator object. Okay, how to get the elements? Okay, here we can use, okay, two methods. What are the methods? Has next and get next. What has next will do? Okay, has next will check, okay, whether element is present in the, okay, data structure or not. Okay, if element is present, based on the return type of this has next, okay, it is going to call get next method. Okay, so here boolean, right, return type is boolean. Has next will check whether elements are present in the, okay, data structure or not. If element is present, it will return true, otherwise return false. False indicates that there are no more elements in the data structure. True indicates there are elements in the data structure. Okay, so now how you can write? So how you will write? I want to get all these methods, sorry, I
Uh,
want to get all these values from list.
Sir, we will put it in the while loop.
Yes, 1 second. ah Sorry. Yeah, see here, iterator has two methods. What
Has next
as
and
next and a get next, right? So here it, okay, it is the object of iterator, right?
I did.
So
Yes, sir.
here we have 300 comma 200 comma 100. So these are the three, okay, elements present in the data structure. Okay, so you no need to worry about the type of data structure. Okay, yeah, now simply I will write what, while, okay, so
IT
it dot
has
has
next.
next. Okay, it dot has next, and here sop of
Next.
it dot get next. It dot get next, that's it. Okay, now what happened? So for first iteration it dot has next. So here your iterator will check, okay, this method will
Present.
check whether elements are present in the, yeah, data structure or not. Here 300 is there, so
It will
what it
return
will return?
true. So then
True. Now it dot get
it will
next
get the
means,
three.
so whatever the element is present at the current position, it will return. Okay, yeah, again it is going to call what,
Uh, has
has
next.
next
Yeah.
method. Now your iterator will move to next position and it is going to check whether elements are present in the what
Data
data
structure.
structure or not. Again it will return true. So it will return,
Two.
okay, element at the current
Yeah.
position, and it again it is going to call what, same has next
Next.
method.
Yeah.
Okay, yeah, again it will return
True.
100.
Yeah.
Again it is going to call,
Yeah.
okay, after 100 also it will call it dot has
Has
next.
next.
Now your iterator is going to check whether elements are present in the, okay, next position or not.
Yeah.
So there is no element at the next position, so simply it will return
False.
false. False means what happened? Loop gets
Oh,
terminated.
I mean, yeah.
That's it. So like this it will, okay, iterate through the data structure and we can get elements by using, okay, iterator. Is it clear?
Yes, sir.
Yeah.
Yes, sir.
Okay. Ma'am, I have done my part, ma'am.
Sir, like I have one question. Uh,
Yeah.
can we have our inner class as public?
Yeah, you can.
So when we have inner class as public, then how do we access it from outside the class, that inner class?
Okay. Second. Test is there, right? Yeah. So, test 2. Yeah. See here. So class, okay, outer, okay, class outer. So class. So your inner class, okay, is can be public, okay, can be public or default, anything. Okay. So as of now, so it is not private. Okay. So it is not private. Okay.
Is
Outer.
it default like right now?
Yeah, default, right? So outer class. This is inner class. So now, so if you declare your class as, okay, other than private, your doubt is if you declare a class, inner class other than private, right? Your doubt is if you declare your class, your inner class as other than private, what will happen? That is your doubt, right?
Like how to create an object of inner
Yeah,
class
yeah,
and
yeah. I'll tell you. I'll tell you. Okay. Yeah. Now you can create, for suppose here are creating method public void show. Okay. Now sys out show from inner class. Okay. Show from inner class. Now your doubt is how to instantiate your inner class, right?
yes.
So simply, actually, inner class, right? So if it is outer class, if your inner class is outside of, okay, outer class, then you can create object like this, right? Inner class obj is equal to new inner class, sorry, new inner class. You can create object directly, okay, if it is not inner class. Okay, but here your inner class is, okay, member of outer class. Okay, member of outer class. So in this case, so here you should write like this: outer class dot inner class obj is equal to, okay, obj is equal to new inner class of, okay. So here you should not instantiate directly like this. So first you should create an object of what, outer class. See, outer class out is equal to, okay, you can make use of outer class object. Okay, yeah, out dot new inner class. You should create object like this because here inner class is what, it is a member of outer class. Okay, it is a member of outer class. So here you should, okay, so you should access this inner class outside, okay, by using its class name like this. Okay, so outer class dot inner class, okay, obj is equal to out dot new inner class. So you should instantiate like this. Okay, why? Because here inner class is what, member of this outer class. Is it clear?
Yes, sir.
Yeah. Now I have one more doubt on behalf of you. So I have one doubt. So if it is private, now you tell me how to
We can
instantiate this inner class,
we cannot create an object of private class.
right? So here I don't want to reveal my inner class name to outside people. I don't want to reveal. Okay, I don't want to reveal my inner class name. Okay, inner class name to outside people. Okay, Yeah, in this case, so we have to define a interface. Okay, so interface. Okay, interface. So here inner class interface. For suppose, okay, inner class interface. Now here I'm forcing your class to I'm forcing your inner class to implement this interface. Implements inner class interface. Okay, so here I don't want to reveal my inner class name to any other outside class. So that's why what I'm doing is here I'm defining, okay, I'm defining what inner class one interface, that is inner class interface. Okay, inner class interface. Now I want to call this show method. Okay, I want to call this show method, and now you tell me how it is possible. Okay, so in order to create, okay, in order to create an object, okay, an object of this inner class, what I'm doing is I'm going to define a method, so that is public. Okay, so public, so inner class get inner object. Okay, get inner object. Okay, so this is my method. Okay, so it will return the inner class object. So return new. Okay, yeah, here what I'm doing is in order to, okay, get inner class object, okay, so I'm giving a method that is get inner object. So this is the, okay, method is used to get, okay, is used to get object of inner class. Okay, object of inner class. Okay, now you tell me, mm, how to get inner class object. How to get inner
Using
class object? First, my question.
interface.
How to get? Yeah.
We can create in a reference of interface. Then,
No, no. First, I'm asking
oh,
how to create inner class object.
Sir, first we should create the object of outer class.
outer. Okay.
Okay. As you said. Okay. As you said, I will do it. Outer class. Okay. Obj is equal to new outer class. Okay. Yeah.
Okay, but it's private class.
Inner class interface is equal to obj dot get inner object.
Yeah.
Am I right, sir?
Yeah. 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 We'll try. Okay. Inner class interface. Okay.
Yeah.
Like this, right?
Yes, sir.
IOBJ is equal to Sanjay.
Obj dot get inner object.
Creating your object.
Yeah, it is clear, right? Here, why to create directly object? So your outer class, okay. So your outer class, okay. So given one method, okay, in order to get the inner class object. So what is that? Get inner object. This object is creating and returning the object, no? Okay, simply create an object of outer class, okay, and call, okay, this get inner object in order to, okay, get the inner class object. Okay, and you cannot assign directly inner class is equal to get inner object, right? Get inner
Yes.
object. Why? Because it is not visible outside. My intention is I don't want to reveal my inner class name to outside people. Okay, that's why I given one interface. What is the interface?
Inner class interface.
Yeah, so now you can, okay, use this interface as interface reference variable to hold my inner class object. Okay. Now IOBJ dot show. Yeah. Here now outside people, okay, cannot know the inner class name. Okay, cannot know the inner class name. They know only what the interface name. Okay, they know only what interface name. Is it clear?
Yes, sir.
Yes, sir.
Yeah. Okay. So, do you have any specific doubt? You can ask. Mehak, is it clear? Actually, this
Yes,
is
sir.
asked by you.
Yes, sir.
Yeah. Okay. Do you have any specific doubt? So you can ask.
No, sir.
No, sir.
Dhanya, ma'am.
Yeah, yeah. Thanks, Anna. So
Okay.
coming Saturday, we'll have weeks 5 to 8, and then possibly coming Tuesday, weeks 9 to 12.
Ma'am, one request.
Yeah,
Ma'am, is it possible to have the next session, which is on Saturday? Actually, it is the timings are from in the evening, right?
yeah.
Is it possible to arrange that session in the morning?
See, the problem is there are app dev sessions happening in the morning, right? So each course has been allocated some particular time.
Mm,
Especially,
mm,
you see, if it's diploma in programming, like there may not be any other course having the live session at the same slot.
yeah.
So,
Okay.
I mean, is it a personal constraint or is it for the OPP for the next day? Or I mean,
Next day we have that in the morning session only, ma'am. 8 to 9:30 we have that
also you
OPP.
want to prepone. So, can we have it on Monday then? Is that okay?
Monday.
No, no, this session, right? Can we plan it on Monday? That next revision session. Instead of Saturday, we'll cancel it. Monday, we will have it.
It'll be useful for us, no, ma'am, because most of the questions will be coming from the 6th and 7th, right?
Oh, okay. So, you want to have it on Saturday itself, but not from 4 to 6, is what you're saying?
Yes, yes, ma'am.
Okay. So, I'm not very sure. I will check because generally, it's such kind of a changing is not possible. I will
Okay.
check and let you know. Okay.
Yes, ma'am.
And earlier is also like okay, like Friday or Thursday. It's also okay.
And again, see, that's a problem. When we check with, so the ops team have to schedule the slots, okay?
Hmm.
And if there are other courses which have live sessions planning, like maybe data science part, like there might be overlap, but with respect to programming, generally there won't be an overlap with other courses for the same slot. So we try to do that. Let me see, but I am not assuring you anything. Okay.
Okay, ma'am.
Okay. Yeah, sure. Okay then. Thank you. Okay.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am.
Thank you, sir.
Yeah, sure. Bye.
Mhm.